Hi guys, this is Mrs. Villette. Before we get started on the actual worksheet, I want to give a little bit more context on what we're going to be doing. We'll be continuing working with identities, and in particular, we're looking for expressions that tell us how to find the cosine or the sine of the sum of two angles. So cosine of alpha plus beta, sine of alpha plus beta. One notion to dispel early is that it is not just the sum of the individual angles, and I'll show you why. So sine of alpha plus beta is not the sine of alpha plus the sine of beta. And an easy example to use is pi over 4. So if we look at the left-hand side, sine of pi over 4 plus pi over 4, we know pi over 4 plus pi over 4 is pi over 2. And the sine of pi over 2 is 1. If we look at the right-hand side, if we were to take the sines individually, sine of pi over 4 plus sine of pi over 4, then we have root 2 over 2 plus root 2 over 2, and since those are like terms, root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, or just root 2. And 1 clearly does not equal the square root of 2. So we'll get to actually finding the correct identity. You can find it on your pink sheet. The goal of this video is actually to derive or come up with what the identity is. We're going to look at two angles, alpha and beta, and at first they're in standard position. But in order to consider their sum, alpha plus beta, what we're actually going to end up doing is move the beta so that its starting ray is the terminal ray of alpha. So what I mean by that is we're going to start beta here, and then we're going to end it, I don't know, approximately right there, so that it's the same angle that I had before. So we see where the beta is right now, but the whole angle starts at the x-axis and goes here. So we're just sort of copying and pasting it and moving it so where it starts is now here and where it ends is now there. It's a much better picture on the next page, but I just want you to have an understanding of the fact that it's not in standard position. Okay, so our goal is to find formulas for cosine of alpha plus beta and sine of alpha plus beta in terms of the sines and cosines of these two angles. So this figure has a lot of moving parts. So in the figure below, the angle alpha is the angle EAG. So let's find that. So I have alpha here, so EAG, that's my angle alpha. And it does go all the way through to hit a terminal side on the unit circle at the point Q. But we're going to be doing a bunch of stuff with right triangles, so I'm considering the similar triangle that's within the circle. Then the angle beta is PAE. So PAE, here's beta, and notice beta isn't in standard position. So like I was explaining on the previous slide, we have actually moved beta so that it starts where alpha ends. Okay, and now we have the angle alpha plus beta. So alpha plus beta is this angle because we've got alpha and then we went beta further, and that is the angle PAG. So alpha plus beta. And I want you to notice that over here I have taken the terminal ray of that angle alpha plus beta and I've intersected it on the unit circle. If I have done that, then the coordinates of those points are the cosine of alpha plus beta and the sine of alpha plus beta. And that's our goal, is to figure out what those are. So notice this r, this length that's labeled r, is the cosine value because that's the x-coordinate of that point. And q is the y-coordinate of the point, so that is the sine. So our goal is to work with all these different parts in this diagram and find equations for r and q. Okay, so to start with, we're going to write equations for the lengths of q and r in terms of the other line segments. The easier one is to do this sine of alpha plus beta, the q side. And I can see over here, here's my q length, and there are two line segments that actually sum to that. So the sine of alpha plus beta is q, which is whatever the length of n is, plus the length of j. We have to do a little bit more work for r, because r is actually negative. So if I take the opposite of r, that will make it positive. If I add that to s, I am going to get this line segment that I have that's called I up here. I don't have the right color for that, so r, opposite of r plus s equals I. Now this line segment I, I'm just going to consider it to be positive because this isn't really a standard position angle or a standard position triangle. So even though part of it overlaps into the second quadrant, if we wanted to, we could say absolute value of I. Okay, so if I solve that for r, I get that r, or the opposite of r, is I minus s. Let's just keep it as I. And then r equals negative I plus s. Let's rewrite that as r equals s subtract I. So far all I've done is write the other line segments in terms of each other. So now it says write equations for the lengths k and m in terms of the trig function beta. So first we need to find k and m. Okay, so here's k and here's m, and we do have a right triangle here because the angle on the other side is a right triangle. And it says hint right triangle trigonometry. So if I look at the angle beta, it looks to me like the sine of beta is k over 1. So really that tells me that k is the sine of beta. So let's go ahead and label that on our diagram. So now we know that this k is the sine of beta. Similarly, I can see that the cosine of beta is the adjacent over the hypotenuse, so m over 1, so that means m is the cosine of beta. So we'll go ahead and label that cosine beta. So all I've done is applied right triangle trigonometry to recognize that in this triangle that has beta as one of its interior angles, one of its legs is cosine beta and the other leg is sine beta, and that's because it is actually a full triangle in the unit circle with a hypotenuse of 1. Okay, moving on, write equations for the lengths of s and n in terms of m and alpha. So s and n, s is right here, n is right there. And it says again, the hint is right triangle trigonometry. So I'm just going to write out what the sine of alpha would be. The sine of alpha would be the opposite over its hypotenuse. Notice we have said that its hypotenuse is cosine of beta. That means n is sine alpha cosine beta. So we did the opposite over the hypotenuse. Now we're going to do cosine of alpha as adjacent over hypotenuse. So the cosine of alpha is s over cosine beta. So we now have that s is cosine alpha cosine beta. If you were to look at your pink sheet right now and look at the expressions for the sum and difference formulas, you would start to see some of these expressions popping up. Okay, so now we need to write expressions for the lengths of j and I in terms of k and alpha. So j is right here, and I. This part's a little bit more tricky because we don't know what this angle is right here. What I do know is that within this right triangle that contains alpha, this angle is the complement to that, so it is 90 minus alpha. So let's call this theta, this angle that we're trying to find right here. Those three angles are on a straight line. So here, theta, this right angle, and 90 minus alpha. So I can say that 90 minus alpha plus 90 plus theta equals 180. So I have 180 degrees, subtract alpha plus theta equals 180 degrees. Notice I could subtract the 180 degrees, cancel it to get zeros, and if I solve for theta, I end up getting that theta equals alpha. So it actually turns out that this angle up here is another alpha. Okay, so running through, the hint was again right triangle trigonometry. If I do the sine of alpha, it would be the opposite, which is I, over its hypotenuse, which we have called sine beta. So we have sine of alpha equals I over sine of beta. So I equals sine alpha, sine beta. Now if we do the cosine of alpha, the cosine of alpha in this smaller triangle would be j over sine beta. So cosine of alpha is j over sine beta. Cosine alpha equals j over sine beta. So j equals cosine alpha sine beta. Okay, each one of these expressions that we came up with, I'm going to go ahead and box them out because we're going to use them. The first one that we're going to use is right here. The cosine of alpha plus beta, we said was s subtract I. So s was cosine alpha cosine beta, and we're going to subtract I, so subtract sine alpha sine beta. Then the sine of alpha plus beta we said was n plus j, so n and j, and n was sine of alpha cosine beta plus cosine alpha sine beta. Now go ahead and take a look at your, I should say pink sheet, I guess I must have done it green before. So check these formulas against your pink sheet. Those should actually match the sum and difference identities that are given on your identity sheet. Now, I don't want you to feel like this is a proof that you're going to have to come up with on your own later. I do want you to buy into this identity. So I don't want to just give you an identity and have you go, sure, that looks good, because it doesn't. It's complicated. There's a lot of moving parts. So the purpose of showing you this proof is really to give you better buy-in to using this identity. So the next time that we work with this, we're actually going to be doing things with this identity rather than deriving it. So this video was just to get you an introduction to the identity, and we'll actually start using it later.